Assalamualaikum warahmatullahi wabarakatuh. My name is Abdul Hakim, and today I want to present about the introduction of current state of machine learning in healthcare. Okay, for the current state of machine learning in healthcare, there we have 4 points. First is managing record. Second is predictive analytic and on patient. Third is predictive analytic on equipment, and lastly is predictive analytic on robotic. For managing record is traditionally user had to identify and categorize record as they were being created, which increase workload and reduce productivity. However, within the application of machine learning, the time-consuming task of analyzing record can be made easier. This eliminates the need for user to assign a category to each record they create, streamlining the process and potentially reduce error in classification. For managing record, there are 2 points. First is supervised learning and unsupervised learning. For supervised learning is a subfield of machine learning and artificial intelligence. Its defining characteristic is the use of labeled dataset for training algorithm to accurately perform data classification and prediction. For the unsupervised learning employ machine learning technique to examine and categorize raw data for insight. This automated procedure find previously unknown relationship between data point. For input data for supervised learning, the input data is provided to the model along with the output. For the unsupervised learning, only input data is provided to the model. Next is the predictive analytic on patient. Predictive analytics in healthcare aims to anticipate a patient's future condition based on their likely progression and the potential impact of specific treatment. This process assists in developing treatment strategy that ensure the highest level of patient care by utilizing data and machine learning. Predictive analytics help identify patients at risk and enable the provision of preventive care to mitigate the future health issues. For the predictive analytics on equipment, predictive analytics in healthcare enable efficient monitoring of equipment by utilizing network access and appropriate tools by accurately predicting equipment failure. Hospitals can proactively manage their resources and reduce the costs associated with addressing unforeseen emergency. Additionally, having a clear understanding of maintenance requirements in advance ensure the proper upkeep of medical equipment, further contributing to cost reduction and efficient healthcare operation. For predictive analytics on robotics, machine learning is the process of training artificial intelligence model by providing instruction and sufficient data. This enables efficient functioning of AI module, including robot. In the field of robotics, one of the key applications of machine learning is object recognition. Machine learning algorithm assist in recognizing a wide range of objects, considering their various shape, size, and context. Object recognition is a primary use of machine learning in robotics, contributing to their effective operation. Next we go to the overall architecture. For the overall architecture, we have a 4 points. First point is introduction. Second is research background. Third is a problem statement, and lastly is solution based on conclusive support evidence. Okay, for the introduction, for this machine learning, we choose lung cancer for our assignment. Okay, introduction. Lung cancer is a common and serious disease that affects the lung. It is a leading cause of cancer-related death globally. Factors such as smoking, environmental pollutant, infection, genetic predisposition, and autoimmune disorder contribute to the development of lung disease. Although smoking poses the highest risk, non-smoker can also develop lung cancer. The duration and quantity of smoking increase the risk, but quitting smoking significantly reduce the likelihood of developing the lung cancer. For research and background, lung cancer is a complex and multifactorial disease that involves that involve the uncontrolled growth of abnormal cells in the lung. It is one of the most prevalent cancer worldwide and leading cause of cancer related to death. Extensive research has been conducted to better understanding the risk factor of the lung cancer. The risk factor of lung cancer can be broadly categorized into two main groups. First is modifiable risk factor, and second is non-modifiable risk factor. For the modifiable risk factor, first is smoking. Cigarette smoking is the most significant risk factor for lung cancer. It estimates that approximately 85% of lung cancer cases are caused by smoking. The risk increases with the duration and quantity of the smoking. For the next is the second-hand smoke. Okay, exposure to the tobacco smoke from other or we call passive smoking increase the risk of developing lung cancer, especially in non-smoker. And last, for the modifiable risk factor is quitting smoking. While smoking cessation reduces the risk of lung cancer, it may take several years after quitting for the risk to decrease significantly. For the non-modifiable risk factor is a family history. Individuals with a family history of lung cancer have an increased risk of developing the disease. This suggests a possible genetic predisposition to the lung cancer. Second is a radon gas. Human that exposed to the high level of radon are radioactive gas that occur naturally in the environment increase the risk of a lung cancer. Radon can accumulate in buildings, particularly in poorly ventilated areas. And last but not least is occupational exposure. Certain occupational exposure to carcinogens such as asbestos, arsenic, chromium, nickel, coal product, and diesel exhaust can increase the risk of lung cancer. Okay, next we jump to the problem statement. For this part, we have 3 points for the problem statement. First is the increased expense is necessary because it is the only way to obtain the data and tool for prediction. Next, third point is the patient did not receive appropriate medical therapy in order to diagnose the condition. And lastly is the accuracy of human judgment is subject to the possibility of inaccuracy. Okay, for the last part for the introduction is a solution for problem statement. For the first solution is automation reduce cost and improvise accuracy, such as echocardiogram, CT scan, MRI are used to diagnose cardiac problem. Next is based on the prediction. The patient can be appropriately diagnosed with lung illness and receive the appropriate therapy from any hospital specializing in treating lung cancer. And last, since automated systems are not vulnerable to the same kind of mistake that may be made by human, they can be utilized in decision support system for medical practice.
Okay, Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Fadil bin Muhammad Fuad. Thank you to my friend. Okay, my part is a type of model use. Use a 6 model, which is first is logistic regression, second Gaussian Naive Bayes, third Bernoulli Naive Bayes, 4 support vector machine or SVM, and 5 random forest, and 6 is K nearest neighbors or KNN. Okay, for the description of model use. Okay, first is logistic regression. First, it's a classification algorithm used to predict the probability of an event occurring. It's worked by fitting a line that best separates 2 classes in a dataset. Okay, the line represents the decision boundary and based on where a data point falls in a relationship to this line. Okay, we can classify it into one of the 2 classes. Okay, next slide is Gaussian Naive Bayes. This is a probabilistic classifier based on a Bayes theorem. It assumes that the features in a dataset are normally distributed. It calculates the probability of a data point belonging to a particular class by combining the probabilities of each other. All features are independent of each other, which simplifies the calculation. Third is Bernoulli-Neff Bayes. It's a similarity to Gaussian-Neff Bayes. This classifier is based on Bayes' theorem. However, it is specially designed for binary yes or no feature. It assumes that each feature follows a Bernoulli distribution, meaning it can take only two possible value, each which 0 or 1. Okay. Next is support vector machine or SVM. SVM is a versatile algorithm for both classification and regression tasks. It works by finding the best possible decision boundary that separate different classes by maximizing the margin distance between the decision boundary and the nearest data point of each class. Okay, SVM can handle complex data sets by mapping them to higher dimensional space. Okay, next is random forest. It's an ensemble learning method that combines multiple decision trees to make a prediction. Each tree in the forest is trained on a random subset of the data and a random subset of features. When making prediction, the random combines the prediction of all the trees to determine the final output. This technique improves accuracy and helps mitigate overfitting. Okay, last one is KNN or k-nearest neighbors. KNN is a simple but effective algorithm for both classification and regression tasks. It works by comparing a data point with its neighbors and assigning it to the classes or value that is most common among the k nearest neighbors. Okay, the value of k determines the number of neighbors considered. Okay, next I want to present about confusion matrix. Okay, first we need to know the short form of confusion matrix, which is TP. TP is true positive. The next is FP. FP is false positive. TN true negative, and FN is false negative. Okay, for the first confusion matrix is logistic regression. Okay, first TN is TN for this model is 44. TP is 5, while 0 is a value at false negative FN, which is in good sensitivity if face lung disease. The last value in confusion is 7, which is FP. Okay, next for confusion matrix is Gaussian-Neff Bayes model. Okay, for the confusion matrix is first TP is 8, TN is 43, while 1 is value at false negative FN. The value in confusion is 4, which is FP. Next is Bernoulli-Neff Bayes. TP is 8, TN is 43, while 1 is value at false negative FN. The last value is in confusion matrix is 4, which is FP, false negative. Okay, next is SVM confusion matrix. TP is first for TP SVM is 4, true negative 44, while 0 is false negative, which is in good sensitivity if face lung disease. The last is 8 for false positive FP. Okay, for the 5 is random forest model. Okay, the value of confusion matrix is for TP is 4, for TN is 44, while 0 at false negative, which is good. Also good for sensitivity if face lung disease. And the last for FP is 8, and the last model is for KNN. Okay, the value for TP is 9 and TN is 43, and while 1 is a false negative and last is false positive, which is 3. Okay, last is about accuracy for the model. Okay, for the model of logistic regression, the accuracy is 87.5, which is quite high. And next is Gaussian-Bayes model, which is 91.0, which is higher than logistic regression model. And third is Bernoulli-Bayes model, which is 91.07, which is the same as Gaussian-Bayes model. Okay, 4 is SVM. SVM is 85.71 accuracy, which is lower percentage than logistic regression model. For the 5 is random forest, which is 85.71%, which is same percentage as support as SVM. Okay, last is KNN. The accuracy model is 92.6 x6, which is the highest accuracy percentage compared to other 5 model. Okay, that's all from me.
So, Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Nur Isyad bin Husin. Now I would like to present my part, which is the contribution towards sustainability. Okay, this part actually I will explain more toward the improvement in the sustainability factor for the proposed solution. Contributing towards sustainability in machine learning in healthcare is important to all of us, which is the medical engineers, to minimize the environmental impact of data processing. Okay, now let's go to the first part. Okay, the first point here state that we can enhance the resource allocation by applying machine learning models like logistic regression, Gaussian naive Bayes, Bernoulli naive Bayes, support vector machine, random forest, and K nearest neighbors to clinical data. They, which is the healthcare organization, actually can gain insight into disease patterns, treatment outcomes, and the patient characteristic. Okay, all of this information can aid in more accurate resource allocation, including the optimizing staffing levels, allocating medical equipment and supplies, and planning healthcare infrastructure. Okay, and then by efficiently allocating resources, the healthcare organization can reduce the waste and help us to minimize the unnecessary expenses, and also it can help us to enhance the overall sustainability. Okay, next we go to the second point here, which is the early detection and intervention. Okay, for me, machine learning models still have the potential to improve the early detection and intervention for disease, including our datasets, the lung cancer, and by analyzing the large-scale datasets, these models can identify patterns and risk factors associated with the disease. The early detection enables timely intervention, which will help us to leading to improve patient outcomes and probably help us to reduce the need for extensive treatment or hospitalization. Okay, also by minimizing the progression of disease through early intervention, the healthcare system later can achieve long-term sustainability by reducing healthcare costs and the burden on resources. Okay, and lastly, for the third point is personalized treatment planning. Okay, normally machine learning models can analyze patient-specific data and providing them a personalized treatment recommendation based on historical data and pattern. Okay, this will approach of personalized treatment. This will allows the healthcare practitioners to tailor treatment plans to individual patient, optimizing efficacy and minimizing the side effects. Okay, the personalized treatment planning can help us to avoid unnecessary treatment or medication, so that it can reducing waste and healthcare costs, which this actually is the most problem that happen in the medical department. Okay, and then the personalized treatment also can contribute to sustainability by reducing the overall environmental impact associated with healthcare practices, such as the production and disposal of pharmaceuticals. And now we go to the next slide. Okay, the second slide here is the third slide is for part of contribution, which is the environmental impact for the proposed solution. Okay, the first point here is the efficient resource utilization. Okay, in this point, the proposed machine learning solution here enables enhanced resource allocation and allowing healthcare organization to utilize their resources more efficiently. Actually, this includes optimizing the use of medical equipment, also reducing the energy consumption, and we too can minimizing the environmental footprint associated with healthcare operation. Okay, with this, we efficiently can utilize the resources, such as reducing energy consumption in healthcare facilities or optimizing the transportation routes for medical supplies. Okay, all of this indirectly, the solution can help us to reduce the environmental impact related to resource depletion and energy consumption. Okay, we move to the next point, where the second point here is the reducing waste. In this point, we can say that machine learning models actually can help healthcare organization by optimize their process and resource allocation. This will lead to a reduction in waste generation. Also, by accurately predicting healthcare needs, such as demand for medical supplies, medication, or diagnostic tests, unnecessary overstocking and expiration of perishable items can be minimized. Also, by identifying a more efficient treatment pathway, the solution can help us to reduce the regeneration of medical waste associated with unnecessary treatments. With reducing the waste production, we can propose the solution to contribute to environmental sustainability by minimizing the burden on waste management system and reducing the overall environmental impact. So we go to the next point. Okay, lastly, here is the protecting natural ecosystem. Okay, for this point, the machine learning solution actually contributes to environmental sustainability by helping the healthcare organization so that they can make informed decision that minimize the impact on the natural ecosystem. For example, the description here, by optimizing patient care pathways and treatment plans, unnecessary hospital admission or prolonged hospital stay can be prolonged, can be reduced. This in turn will help us to lower the demand for healthcare facilities and frees up the resources, probably by minimizing the need for expanding infrastructure into our natural ecosystems. Also, by protecting our natural ecosystem, the proposed solution for machine learning later will indirectly align with the sustainability goals related to ecosystem conservation. Okay, that's all from me. Thank you.
Okay, next we go to the aspect of future design. Okay, for the first aspect is a quick detection for diagnosing and disease. First is early detection and diagnosis. Okay, machine learning algorithm excel in identifying ailment and diagnosing illness at early stage, enabling time intervention and treatment. This is achieved by analyzing large volume of data and detecting pattern, correlation, and anomalies that may not be apparent to human observed. Early detection allows for more effective and targeted intervention, leading to improved patient outcome. For the second is enhanced precision and speed. Enhanced precision and speed in machine learning algorithm offers superior precision and faster diagnosis compared to human capabilities. By leveraging advanced computational technique, this algorithm can analyze complex dataset with high accuracy and efficiency. This enables healthcare providers to make informed decisions promptly, reducing the time between diagnosis and treatment initiation. For the last part is advanced disease prediction. Machine learning model, particularly deep learning based prediction model, have the ability to forecast disease development in a more advanced manner than traditional approach. For example, a deep learning model can predict the likelihood of lung cancer development up to 5 years in advance. This early prediction allows for proactive preventive measure and personalized intervention to mitigate the progression of the disease. Okay, for the second aspect is enhanced medical research and clinical trial. For the first point is accelerate research and analysis. Machine learning can expedite the process of conducting clinical trial and medical research by analyzing larger dataset and identifying patterns. Machine learning also algorithm can assist in predictive analysis, leveraging factors such as medical history and patient data. This enables researchers to obtain insight and draw conclusions more efficiently, saving time and resource in the research process. For the second point is an improved diagnostic tool. In machine learning algorithm can contribute to the development of advanced diagnostic tool in healthcare. In medical imaging such as X-ray or MRI scan, machine learning algorithm can employ pattern recognition to identify specific pattern indicative of certain disease or condition. This can aid doctor making faster and more accurate diagnosis, potentially leading to earlier intervention and improved patient outcomes. For the last part is enhanced efficiency and accuracy. By leveraging machine learning in healthcare, the diagnostic process can become more efficient and accurate. Machine learning algorithm can analyze medical image such as scan or pathology slide to detect subtle pattern or abnormality that may not be easily detectable by human observer. This assists healthcare professionals in making more precise diagnosis and treatment decisions. For the last aspect is track the health record. Enhanced efficient in for the first point is enhanced efficient in record keeping. Machine learning technology improves the efficiency of maintaining and updating health record. It automated the data entry process, reducing time and effort required for manual record keeping tasks. Machine learning algorithm can extract relevant information from various sources such as patient visit, doctor cases, and treatment record, streamlining the record keeping process and improving data accuracy. And last part is intelligent health record. Institutions are working on development of intelligent health record that leverage technology to enhance clinical treatment, recommendation, and diagnosis. Machine learning algorithm can analyze patient data and provide valuable insight to the healthcare professional, aiding in more accurate diagnosis and personalized treatment plan. This integration of machine learning in health record promote more efficient and effective healthcare delivery. And for the last part is a conclusion. Okay, machine learning offers significant advance in disease detection and diagnosis, providing early detection, more accurate in diagnosis. It also enhances the efficiency and accuracy of medical device, improving diagnostic outcome and overall patient care. And for last part is machine learning has the potential to transform the healthcare industry, driving advancement in medical research, personalized personalized care and sustainable healthcare practice. And that's all from us. Thank you.